Bismillahirrahmanirrahim. This is our second lecture of the second series, Object Oriented Programming. The topic of today's lecture is class inheritance. This is a way to increase the reuse in software. In software development, as we discussed, in software development and software engineering, the reuse is the main focus of all development. The higher the reuse, the better the software. So inheritance is a way to increase the reuse of a software. On this slide, we're going to take a look at that how inheritance can help us to create and organize reusable classes. The concept of the parent class and the child class. In the previous lecture, we have talked about the class and we talked about a UML diagram of the class. A UML diagram of the class is comprised of three sections. The top section represents the name of the class. The middle section represents a list of attributes, and the bottom section represents a list of methods. So in class inheritance, there's a concept of a parent class and a child class. And this relationship between two classes by this arrow with a triangle head on one side of the line is representing the inheritance relationship between the parent and the child class. So the class at the end of the triangle is the parent class, and the class at the other end is the child class. The concept of the parent and child is, if we make a class child to a parent, then the behavior of the parent, some of the members of the parents, they are or they become member of the child as well. For example, take a look at here. We have a public class A extends object. In Java, whether we write it or not, we like it or not, every class in Java is a subclass of object with a capital O. Even if we don't write this extends object, this is assumed to be there. For example, I write public class A only and then the start of the curly bracket. So this extends object is actually implicitly there. It is by default there. So any class not having a parent class is a direct subclass of object class, which is with a capital O, and this class is in the Lang package. So in this class, we have got 1, 2, 3, 4 members. The first member is a private member. The second member is a protected, then public, then protected. So in this example here, we have a private member, we have two protected members, and we have a public member. So only remember, the private members are to the class itself. They are not visible outside the class. Public and protected, they are visible outside the class. Public is visible everywhere. Protected is only visible in a inheritance hierarchy. So what it means, if we have a class A here, this class becoming the child of the class will have the public and the protected member of the parent class. For example, here we say class B extends A. Now the class B on its own has got a private member and a public method. So actually this class directly has got two members written here, but by virtue of inheritance it has got two more, actually three more members. All the public and protected members of the parent class become the members of the child class. So we have got these members here. Now moving on to the next slide. So far we have looked at the use of the public keyword, the protected keyword, the private keyword, and the Modifier means when we don't write anything, then this is known as the default modifier. So we got public modifier, it is to be written. Protected private modifier is to be written. And when we don't write any modifier, then that is the default modifier. The default modifier is the package. So as we can see here, these modifiers are visible in the class. So public are visible in the class, protected are visible in the class, no modifier are visible in the class, private are visible in the class. Privates are only visible in the class, they're not visible outside the class, whether it is in package, subclass, or any other class or any other program outside the package. No modifiers are visible only in the class and in the package. If the class, the subclass is placed outside the package, it is not visible. Any program using a class with the no defined, not written modifiers will not have access to it. Protected are visible in the class, in the package, and in the subclass, whether in the package or outside in the package. Public are visible everywhere. So we have seen the use of all the modifiers except this one. This one is the one when we don't write any modifiers. The inheritance relationship is also referred to as is a relationship. Is a relationship means the one is a kind of another. So this child class is a type of parent class. So B is a type of A. A is a type of object. What is the meaning of these types? Let's take a look at the next example here. So when we say is a relationship, as you can see here, we create an instance of A class, then we create an instance of B class, then we call a method of class A, and then we call a method of class B. So we actually create instances, objects from classes, and we use those to access the members of those classes. So objects of child class are objects of the parent class too. So that means the B is actually a type of A as well. In the previous slide, we looked at, we got method A, method A1, method B. So here, the B object has got how many members? 2 members on its own and 3 members from the parent. So it is got 5 members altogether. Constructors are not inherited. What are constructors? Constructors are special methods. We talked about this in the previous lesson. They are special methods. They are actually used to create the object. So this A here with the round brackets and B with the round brackets shows that they are methods. As we discussed previously, anywhere you see round brackets, that is an indicator that there is a method. So capital A with 2 round brackets, capital B with the 2 round brackets, these are the names of the method as with the class. The class has got the name capital A, the method has got the name capital A. So this is actually a constructor. Constructors are special methods. They are used, they are called to create the instance of an object, and they are always called with a new keyword. As you can see here, we are calling a method A of A object. We are calling a method B of B object. The call of the constructor is always with a new keyword. Without the new keyword, the constructor cannot be called. So by saying new, we are actually creating an instance of a constructor. Constructors are not inherited. We use the super keyword to access the constructor of the parent class that we'll see in a minute. Creating new enhanced classes by using the existing classes. So is a relationship and inheritance. The purpose is to create the new classes by enhancing the previous class. So we have a class A with certain behavior, and we enhance the behavior of the class by inheritance by is a relationship. So B has got, or we can say the B is an enhanced version of A because it has got the behavior of A by inheritance, and it has got some more behavior or features on its own. Here is the example of the constructor. If we don't write a constructor in a class, the no argument constructor is always written, is always there. As you can see here, we never write a constructor for class A. We never write a constructor of class B, but the compiler will insert, will add a constructor which is the no argument constructor for A, and a constructor which is the no argument constructor for B by default. If we write a constructor on our own, then the compiler does not add a constructor. Okay, this should be remembered, that if we don't write any constructor, the no argument constructor is added by the compiler. But if we write a constructor, then the compiler will not add any new constructor, any default constructors. So here in this example, the purpose of showing this little example from the detail and detail book is to show that how the constructors and the finalizer, we have talked about the finalizer previously in our previous lecture. We talked about the constructor as well. So here we talk about the new keyword super. The super is used to access the immediate parents members. So if a super is used by this super, we are actually accessing the finalized method of the immediate parent. So the immediate parent of A is the object. As we know, this is the class B extends A, class A, and we did not write here the default part, which is not shown here, extends object. So we are here, we are calling the immediate parents. Who is the parent of B? The parent of B is A. So the immediate parent of B's finalized method is called here. So that's finalized method here. So you can see here, we've got 3 classes in an inheritance chart, in a hierarchy, and we create an object, C1 new C, and then we assign null value to it. When we assign null value to it, that means this object is no more required. And by calling the system.gc, the garbage collector will come into action and clear the memory. So it will actually clear the memory for C1. When we create the instance, create an instance of C, and then when we clear an instance of C from memory, what actually happens? The output is shown here. So by creating an instance of C, actually the C, before the actual C message comes up, the object of C is constructed, the B gets constructed. Before the B gets constructed, the A gets constructed. So this is the default behavior. As you can see here, in C here, we write this message here. So this message actually is displayed at number 3. What are the other messages? The other messages are coming from the parent classes. So you can see here, by creating an object, by calling a no argument constructor, internally they are calling the constructors of the parents. So the parents objects are created first. This message shows that, and then when we clear the memory, the actual object C's memory is cleared first, then the B's memory, and then the A's memory. So this is in reverse order. For the creation, the objects gets created after a parent gets created. But when we destroy, the object memory is destroyed, and then the parents memory are destroyed in a sequence. So this actually is showing the sequence of actions taken place to create an object C. So if a child constructor invokes the parent constructor by using the super reference, it must be the first line of the code of the constructor. So if within a constructor, if we need to call the constructor of the parent class, it must be the first line. As you can see here, we never access the constructor, but this is the default behavior of creating or constructing an object. But if we want to have a control in our hand, and we must call the parents class constructor, then it should be the first line in the constructor. This is the condition. Okay, we have talked previously about method overloading. Just a quick reminder, method overloading is when we have 2 methods with the same name but different parameters. So altogether the signature of a method is the name of the method and the list of parameters passing into the method. So two methods with the same name and same signature, so different parameter list is called within the same class is called the method overloading. Method overriding is the concept which is in inheritance. When the parent and the child class have got the methods, both with the same name, with the same signature, but different behavior. As you can see here, method A has got some behavior here, but we change the method A's behavior in the child class. So whatever we write here, the actual behavior of the parent class is changed. Okay, here is a typo. Let me just correct the typo. In here, I want to show that if I want to use the inheritance and the overriding, then how it should behave. So actually what I've done here in method A, before I change or add the new behavior, or before we actually enhance the behavior of method A, we call the method A of the parent class by the super keyword. So the super is a special keyword which can be used to access the members of the parent class, and if we are using it directly, as we talked previously, without any point and any member name, just super round brackets, and that is a call to the constructor. So the method overriding once again, the method of a parent class, if it is changed or enhanced in the child class, this concept is known as method overriding. So the behavior of method B.